Alright, the following is number 143 on page 210, Whetstone forces of Constrain. Basically what the problem said was a ball of unknown masses is attached to a spring in outer space. Far from an object, you hold the other end and you swing the ball around, and the ball is at a constant speed. And then it wanted us to find the speed of the ball and asked if the momentum is changing. If it is changing, what are the interactions causing it to change? And then it gave us a scenario, and it was asking us to find the magnitude of the force and the mass of the ball. So the first part, what is the speed of the ball? So they said for 10 revolutions, it took 6.88 seconds. So we firstly solve for one revolution, which takes 0.688 seconds. So this means that for one whole revolution, it took 0.688 seconds. Now we convert the revolution to distance, which is 2 pi r, or once again radius was given. So to find the velocity, we simply take the distance, 2 pi r, and divide it by the time it took for it to make one revolution, which is 0.688 seconds, and then we get the velocity of 13.6988 meters per second. The units do check out here. The distance is in meters, and the time interval is in seconds. So velocity, the units are meters per second. The second part of this question was, is the momentum changing? Well, momentum is a vector quantity, so even though it's at a constant speed, that means that it's at a constant force, the direction of it is changing. Because the direction is changing, yes, the momentum is changing, because momentum is a vector quantity, meaning it has magnitude and direction. And as we can tell by the diagram, the direction is constantly changing. So the magnitude is constant, but the direction is changing. The part C was if it's changing, what interactions. So the force applied to it, and then the spring also exerts a force. So that is what's causing it to. That's what's interacting with the actual mass. And lastly, we were given a scenario with a radius, the spring stiffness, and the length of the spring, and it wanted us to find the magnitude of the force and then the mass of the ball. So first, what I did was I found the mass of the ball. So it gave us the spring stiffness, and then it gave us the final and the initial length. So you can find the how far it's stretched. Once you find that, you have the force of the spring on the ball, which was 300 newtons, and then you can do F equals m times v squared over r. They gave us both they gave us v and r, so you can simply solve for m by doing m equals f times r over v squared, and we get the mass of 2.40170 kilograms. The units here do check out. If we go back and look back, so we have units of force. Well, we have newtons equals kilograms times meters per second squared over r. One of the meters cancels out with the velocity, and then when it's multiplied by a force, we have kilograms times meters over meters squared over second squared.